Hey kiddos, in this video we're going to go over the study guide for the semester 1 exam. So when we take a look at question number 1, we are asked to find what's the value of 2 to the third power, which simply means 2 times 2 times 2, which is equal to 8. For question number 2, it's a question about order of operations. And so for this question, following our order of operations, we would do whatever's in the parentheses first. So 12 minus 2, which is 10. And then our exponents, 3 to the second power, which is 9. So this would be equal to, and then multiplication, 5 plus 40 divided by 9. And so this would be equal to 45 divided by 9, which is 5. So this would be equal to 5. Question number 3 is write 264 times 264 times 264 as a power. And this is where it would be just 264 raised to the third power because it's being multiplied 3 times. And then for question number 4, list all of the factors or factor pairs for 66. Well, that's 1 times 66, 2 times 33, 3 times 22, and then 6 times 11 would be all of the factor pairs for 66. And then for number 5, write the prime factorization of 56. Prime factorization is where we're once again going to have only prime numbers as factors for whatever our value is. And so for 56, 2 times 28, 2 is a prime factor, so that we're going to circle that. For 28 would be 2 times 14. Again, we're going to circle 2 because 2 is another is a prime number. And then 2 times 7 are the last two factors. So now the prime factorization for 56 would be 2 times 2 times 2 times 7. For question number 6, question number 6, we are finding the greatest common factor for 24 and 54. For question number 6, the greatest common factor would be 6. For question number 7, the greatest common factor for 16, 32, and 72 would be 8. And the greatest common factor for 52 and 65 would be 13. Now remember, factors are merely the values that we would multiply in order to get that number. And in this case, if we're looking at question number 6, 24 and 54, what are all the values or all the factors that are in common between 24 and 54? And then whichever is the greatest, that's the greatest common factor. For question number 9, 10, and 11, we're looking to determine what is the least common multiple. Now, when it comes to multiples go on and on forever. So, for example, for number 9, 9 is one of the values. What are the multiples of 9? 9, 18, 27, 36, 45, 54, and so on and so on. Remember, factors stop. There's a finite amount of factors, whereas multiples do not. Multiples go on forever. So the lowest common multiple for 9 and 24, and for questions 9, 10, and 11 are as follows. The lowest common multiples for 9 and 24 will be 72. The lowest common multiple for 26 and 39 would be 78. And the lowest common multiple for 6, 12, and 14 would be equal to 84. For question number 12, you're asked, you have 16 yellow beads, 20 red beads, and 24 orange beads to make identical bracelets. What is the greatest number of bracelets that you can make using all of the beads? Well, in this example, because we're being asked to find the greatest number of bracelets, that means we're going to have to be finding what's the greatest common factor between these three values. The greatest common factor for 16, 20, and 24 would be the factor that they all have in common, which happens to be the number 4. So that means the number of bracelets that we would be able to make would be 4. Question number 13. A bag contains an equal number of green marbles and blue marbles. You can divide all the green marbles and blue marbles, green marbles. Let's try that one more time. You can divide all the green marbles into groups of 12 and all the blue marbles into groups of 16. What's the least number of each color marble that can be in the bag? So now in this example, we're going to be looking for the least common multiple for these two values, and these two values being 12 and 16. So we're looking to find what's the least common multiple for 12 and 16. The least common multiple for 12 and 16 is 48. 12 times 4 would give us 48, and 16 times 3 would give us 48. So the lowest common multiple, or the least common multiple, would be 48. Question number 14. The ages, let's scroll this up so you can see it. Question 14. The ages of the members of a family are 65, 58, 27, 25, 5, and 2 years old. what is the admission price for the family to visit the zoo? So 65 and older, or excuse me, 60 and older, according to this would be $10. So we have one person at $10. 58 are between the ages of 13 and 59. So there'd be three people are between the ages of 13 and 59, and they would be at $12 each. So 12 times 3 gives us $36. And then we have two people who are under the age of 12, and they are charged $8. 8 times 2 is 16. So the total for the entire family would be 16 plus 36, which gives us 52. And then 52 plus 10 gives us 62. So this family would be paying $62 to attend the zoo or to gain entrance to the zoo, admissions to the zoo. Question number 5. A competition awards prizes for fourth, third, second, and first place. The fourth place winner receives $5. Each place above that receives a prize that is 5 times the amount of the previous prize. How much prize money is awarded? And so for this, if fourth place is awarded $5, third place is awarded 5 times that, which would be $25. Second place would be awarded $125 because 5 times 25 is 125. And then first place would be $625 because 6 times, because 125 times 5 would be equal to 625. So this would earn first place would earn $625. And last but not least, for Unit 1, you buy a tea light candle and mints as party favors for a baby shower. The tea light candles come in packs of 12 for $3.50, and the mints come in packs of 50 for $6.25. What's the least amount of money that you could spend to buy the same amount of candles and the same amount of mints? So, what are we looking at? In this example, we're looking to find what's the lowest common multiple for 50 and 12. Now, the least common multiple for 50 and 12 is going to be 300. It's going to be 300. And so what does that mean? That means for the mints, we'd have to buy 6 packs because 6 times 50 would give us 300. And so 6 times the $6.25 in order to get, whoops, times 6. So we'd have to spend $37.50 on the mints. Excuse me. And then for the tea light candles, we'd have to buy 25 of those because 12 times 25 would give us 300. So 12 times $3.50. This would be equal to $42. And so the sum of these, $42 plus $37.50, would give us $79.50. So the least amount of money that we would spend to buy the same amount of tea light candles and mints would be $79.50. So at this point, you can pause, look over your answers, look over and review what you got for these 16 or so questions for Unit 1. We'll move on to Unit 2 in just a moment.